Hi everybody, this is Mrs. Costello again. I did the day 2 video and now I'm back for day 7, day 8. This is unit 1, day 7. We're going to talk domain and range today. Again, we're still reviewing stuff from Algebra 1 because it's been a while since we've done Algebra 1 and this stuff kind of builds on itself in Algebra 2. So when you're talking about the domain, you're talking about all the x values in a set or a line, like a line on a graph. And we're going to work with both of those. We're going to work on, a set of numbers and then a set or a line on a graph. And then the range is just the opposite. We're talking all the y values in a set or a line. Now, the only thing that I want to add to this vocab box is make sure that you're only listing the numbers one time, because sometimes, like, if they repeat, you don't have to say that you already said once that it was in the set, so you don't need to say it again. So only list the numbers once. And I'll kind of show you what I mean as we go through some of these examples. All right, so we do have this function over here, and we could do this one as an example if we wanted to, but we really don't have to. But you might see a graph like this, or you might see like a number set like on number 1 and 2, and we'll talk about like the domain and range on those, right? Because you have an x here and a y here, so we'll talk about what's being represented on our graph. All right, so number 1 and number 2 are both sets. So what we're gonna do is for the domain and for the range, it says to just find the domain, but I'm just gonna find the range too, because why not? So for your domain, you're just looking at those x values. So when you start to list the domain, you do use those curly brackets, and then you just make a list of the numbers. So I'm only looking at the x's. So 3, 5, right, -10, 2. We know those are all of our x's, so we just make a list. It does not have to be in order from smallest to biggest. Sometimes you see it in order, but we're not going to mark you down if you don't put it in order. It's not a big deal. All right, now for our range, we have -5, -6, 5, and 0. So that's going to be our list inside of our curly brackets, because those are all the y values in our set. So we just make a list and say, hey, here's all of our values. Same thing on number 2. Okay, we are going to list our domain first. So we've got -5, 2, 3, and we have another -5. So I'm not going to put a circle around that one, because when we make our list, like, we're already saying that -5 is part of the x values. So you don't have to include that extra -5. So we can just stop there. And that's our range. Or sorry, our domain. Now we're going to do the range. And same thing with the range. We have 7, 3. There's another 3, so you don't have to list it twice. And then a -5. So those are the numbers in the range. Now the rest of the examples are graphs. So when we do the domain and range of the graph, on this particular graph, these are points. So like they have coordinates, which are kind of like what they were in number 1 and 2. You just have to actually find the coordinates to list them. So we're going to actually make a list on these ones. So this point, what I'm going to do is I'm going to write out all the points because I found them ahead of time. So this is -9, -10. This one is -7, -6, -5, -2, -3 and 2, and -1 and 6. All right, and we're going to kind of squish in that right here. We're going to make a list. So -9, -7, -5, -3, -1. And then same thing with the range. We're going to make a list of the y values. So all these guys right here. So -10, -6, -2, 2, and +6. Because they're points. So you don't want to like say, oh yeah, the x's go from -9 to -1, because there's all this empty space right here where there's nothing. So that actually doesn't really count as part of the domain and part of the range. Now on number 4, it's a line. So we're going to do something a little different, but this is what it looks like when you have either a list of numbers or points on a graph that are not connected. Now this is a straight line. This is going to change things because there's all kinds of stuff like inside the line, and we really don't want to take the time to go, okay, I'm going to list every single x from here to here. Like I don't really want to do that. If you want to do that, I mean, it's going to take a really long time, but we're going to list them from here to here, right? That's as far as our x's go, because this is the x and this is the y. So my x's start right here. Okay, this point is at -9, 1. So the x is going to start at -9, and then they're going to go all the way over here to, I think this point is 9, 9. Now here's the deal. You're not just including the whole numbers. You're including all the little teeny tiny pieces, like when it goes through halfway. So you're including like 2.5 and -1.3, like those are still part of the range. So what we do is we create what's called an interval. Okay, now we're going to talk more about intervals tomorrow or in the day 8 video, but when you do an interval, because you have these closed circles right here, you're going to put little brackets. That means I'm including. So I'm including -9, smallest, all the way to +9, the biggest. In Algebra 1, you might have learned it with inequalities. Okay, if you do it with inequalities, when you have like an in-between like this, you put the variable in between, and then you put the smallest and the biggest on each side. So -9 and 9, this is how I teach in Algebra 1. And then I just have them stick in the inequalities like that. So my x's start at -9, they go all the way to +9. Same thing with the range. Now the ranges are the y's, so I'm going to start with my smallest y. My smallest y is 1, so I'm going to put bracket 1, comma, biggest y, which is 9. Or I'm going to use my inequality. I'm talking about the y's, so this time I'm going to put y in the middle. I'm going to put my smallest on the left, biggest on the right, and then put the inequality signs in there. The less than or equal to. So this is saying y is in between 1 and 9. And hopefully that makes sense to you guys. I know the inequality is kind of tricky. So if you have a hard time with it, it's okay. It's a little tricky. I'm going to do the same thing on 5 and 6. Okay, so on 5, when we're talking about our x's, we are going to include everything. And this one's kind of funky because like we see that it starts kind of right here, right? This is probably our smallest x. A lot of you want to say that this is our biggest x, but we've got this guy right here and it continues. So the one on the bottom, the furthest to the right, is actually your biggest x. Okay, so this point right here that I highlight, the first one that I highlighted in green, this is at -8 and -1. Let's see. There we go. This guy right here is at 1 and -8. All right. So my x's are starting at my smallest, which is -8, going to my biggest, which is 1. Or if you're doing it in that inequality notation, you put your x in the middle, -8 on the left, biggest on the right, which is 1, and then put your less than or equal to's in there. Now, same thing with the range, okay? So the range, this -8 right here is definitely going to be my smallest, and then I'm going to go all the way up here to this one that we didn't use, this dot that we didn't use right here. That's my biggest. So this point is at 0, +8. So +8 is going to be my biggest 8. So if I'm using the interval notation, I'm going to start with my smallest, which is -8, to biggest, which is +8. Or if I'm using that inequality, then I'm going y in the middle, smallest on the left, biggest on the right, put in the less than or equal to's. So this is saying, you know, the y's are in between -8 and +8. We got the tree. The tree kind of throws some people off, but like you can still do it. You just have to kind of think about, okay, for my x's, right? X is here, y is here. So the x's are focusing on like how wide that tree is. So we want to find the widest parts of the tree. So the widest parts of the tree is definitely like right here at this leaf and right here at this leaf, right? That's as far wide as the tree goes. So that's going to be our x's. The x right here is it's really hard to see. So what I do is I try to find a spot, like right here is where I see the axis, and then I count over to be able to like figure out what that tree's at. 1, 2, 3, 4. Okay, so it's at -4 for the x. Okay, I don't really care what the y's at 0. And then this one's at 1. You can start way down here if you need to. 1, 2, 3, 4, 5 for the x. So that's going to be my domain. Okay, smallest -4 to biggest +5. Or if you're doing your inequality, right, x is in the middle, smallest on the left, biggest on the right, less than or equal to's. Boom. Same thing with the y's. Now with the y's, you're talking about the height of the tree. Okay? So you're going to start way down here. Bottom of the tree to the very top of the tree right here. Okay? And again, if you need to like draw these out really, really, really long and then count from the x-axis to see what those values are, you totally can, because it is really, really hard to see. So let's do our smallest first. Our smallest y is 1, 2, 3, 4, 5, 6. So -6. Okay, and then the biggest y is 1, 2, 3, 4, 5, 6. 6 again. So smallest y is -6. Biggest y is +6. Or if you're doing your inequality, put your y in the middle. -6 to 6. Put your less than or equal to's. Okay, not bad. All right, we got a few more, and I kind of want to just do all of them. I know sometimes we pause the videos, but they're kind of funky, and I want to really make sure like we got them down. All right, so all the ones that we've done have had like a start and a stop. This one is different, and you really have to think about like what is going on with the x's and the y's, because you got this arrow now. So arrow means it's going on forever. There's no start, there's no stop. Okay, so you have to really ask yourself what the x's and the y's are doing. So let's start with the x's for your domain. Are the x's getting bigger or are they getting smaller? Well, that arrow's pointing to the left, so that means smaller x's. Okay, so small x's. So what that means is when you're doing your interval and you start with your smallest, it's going on and on and on and on and on forever and ever and ever. There is no smallest. So what we do in our interval is we start with -infinity because it's going on forever. And then we see what our biggest is. And our biggest is right here at the end. Okay, this one has a finish. So at the end is 8. Right, 5, 6, 7, 8. Yep, cool. Now, this is going to take some getting used to, but you are going to get really, really good at it throughout Algebra 2 for sure. Now let's look at what our y's are doing. We need to do the inequality. Or if you're doing the inequality, we just talked about the x's are getting smaller. So you're going to actually start with the x this time and say less than or equal to, because they are getting smaller. And that arrow's pointing to the left. 8. Now let's talk range. The arrow is going up. I know it's going to the left, but it is technically going up. So we're getting big y's this time. When we're getting big y's, we need to really look at this start-stop position because this is going to be your smallest since the y's are getting bigger. So this one starts at, this is at 8, 1. So that means my smallest y is going to be 1. So I'm actually going to bracket that. Ooh, I made a mistake over here. This needs to be a bracket, my bad, because that is a closed circle. Okay, infinities never, ever, ever get brackets because you can't include infinity. It goes on and on and on forever, so you can't like actually include it. So 1, and then it's getting bigger, so my biggest value is infinity, parentheses. And then if you're doing your inequality, we just said the y's are getting bigger, so you'd put greater than or equal to 1. Okay, we got a few more like that. So if you're not totally sure about the infinity parts, it's okay. We're gonna keep moving with it. Okay, this one, same thing. Our x's are, let's see, so if you started, we do have a smallest x, right here. This is kind of where the x's begin, but this time the x's are getting bigger, right? Big x's. So we're kind of doing the opposite of what we did last time. We got to find what that x is. And the x's start at, they actually start at -1 and 3. It's really hard to see that that's a -1, but it is. So I'm going to put a bracket and I'm going to put -1 because that's my smallest. Now there's arrows going to the right, so that means the x's are getting bigger, so they're going to go towards infinity. Or if you're using your inequality notation, I just said big x's, so x is greater than or equal to -1. All right, now let's talk about the y's. This part can kind of get funky. Now, if I start at the very bottom of my graph and I try to find the smallest y, the first thing I hit on my graph is an arrow, which means the y's are getting smaller and smaller and smaller and smaller and smaller, right? So my smallest is -infinity. If I keep going up my graph, the y's are also getting bigger at the same time, which means I am now going to positive infinity. So double arrows totally means -infinity to infinity. That's the interval way of saying that. Some of you guys are very used to seeing all real numbers from Algebra 1 when there's double arrows like that. We got a few more. Again, if this is tricky, it's okay. The interval notation is really tricky, but you will become like pros on it by the end. Okay, this one with my x's, right? If I'm looking at the x's, the first thing I hit, arrow. So start with that -infinity because those x's are getting smaller and smaller and smaller. Same thing over on the right side. I hit an arrow again. So looks like I'm going to have that -infinity, or all real numbers. Now, some of you guys, when you just saw me do that, you were probably like, but the arrows are pointing up and down. Yeah, they are. So that means like the y's are also getting smaller and smaller and smaller and smaller and bigger and bigger and bigger and bigger at the same time. Okay. I know when they point up and down like that, it's really hard to see the -infinity to infinity on the x's, but it's a lot easier to see it on the y's. Okay, just know that if they're both going in that direction, yeah, they're going down. That also means it's going to the left and the right too, just not as drastic. Okay, last one. Okay, let's talk x's. So when I start off on my graph, the very first thing I hit, you see my little cursor going across, is this right here. Arrow, right? So -infinity is going to be my smallest. And then when I keep going for the x's, the very last thing I hit is another arrow, which means infinity. Okay, so the domain is an all real number. The range is a little different though, because if I look at this, the arrows are both pointing up, which means the y's are getting bigger, big y's. So this is kind of a mix of both. So if it's big y's, I need to find the smallest y first to start my interval. So the smallest y is going to be way down here. Okay, that's going to be at -9. So I'm going to start my interval with the -9. I just said the y's are getting bigger, so that means they're going to infinity. So I'm going to close it, or close it with a parenthesis. We never ever include infinities. It's going to take some time to get used to it. It's all good. We will be patient with you. Now, if I'm doing the interval or the inequality notation, I start with the y. I said they were getting bigger, so I'm going to put greater than or equal to, and then that -9, because that's where I start. That's my smallest. All right, so those are the notes for day 7. If you're having a hard time with the interval, it's okay. You might have seen in Algebra 1, but it might be new, so don't worry about it. We will work on it. If you have questions, let me know, let your teacher know, so then you guys can really get this down, okay? Have a good rest of your day.